Problem 2 gives us the graph of a velocity of a person in miles per hour at time t hours. And it says estimate the displacement over the time interval from 0 to 4. So what we've got going on here is, remember, if you're looking at velocity, velocity is the derivative of position. So if I integrate velocity from any value a to b, by the fundamental theorem of calculus, its antiderivative is going to be the position function evaluated at b minus the position function evaluated at a. So finding the area under the curve for the desired area is actually going to give you the displacement. So if I set up the integral from 0 to 4 of the velocity function, that will give me my displacement. So remember, integrals give us net area. So if we look at this, it really looks like it's two triangles. So from 0 to 2, right, this is negative area. I'm going to have minus 1/2. This triangle has a base of 2 and a height of 2. And then I'm going to add that to this triangle. So it's going to be 1/2, a base of 2, and a height of 1. And this 2 cancels, this 2 cancels, and I get negative 2 plus 1, which is negative 1. So this particle went negative 1 miles. So that could have been south, right, or west. We don't know because we weren't given the direction of what is negative in this particular case. So we just know it's negative 1, whatever our coordinate system was. Then it says estimate the total distance traveled. So here we got a negative area, the object was moving in the negative direction. Here we got positive area, the object was moving in the positive direction. But if we want to get the total distance it traveled, well, then you calculate the total area. So total area, we don't treat this portion as negative anymore. We just simply calculate the area and add it all up. So if we look at this, the area is now positive 1/2, 2 times 2, plus 1/2, 2 times 1, and now I get 2 plus 1, which is 3. So the object traveled 3 miles. 2 of those miles were in the negative direction, 1 of those miles was in the positive direction, and that's why the net displacement turned out to be negative 1. Problem 3 gives us a velocity equation now instead of a velocity graph, and it wants us to find the displacement of the particle from 0 to 3. So now we can just set up the integral from 0 to 3 of this function, and we can calculate it using the fundamental theorem of calculus. So the antiderivative is 3 cubed over 3 minus t squared. When you divide by 2, the 2's cancel. And we'll evaluate this from 0 to 3. So we plug in 3 first. So I get 27 over 3 minus 9. And then I can see that when I plug 0 into this entire function, I'm getting 0. And 27 divided by 3 is 9. So 9 minus 9 equals 0. So what this means is if the displacement was 0, the particle ended up exactly where it started. It just ended up in the same position as where it started moving. And then it says find the total distance traveled by this particle from 0 to 3. So in order to do that, I need to actually, and on the graph before, it was very easy for me to see the areas and just make all the negative areas positive. But now what I need to do is I need to calculate the positive area and subtract the negative area from it. So I need to know, well, when does this function go from positive to negative? And I can figure that out by setting it equal to 0. So f of t equals 0. And in this function, I can factor a t out front. So I've got t times t minus 2. So this thing's 0 at 0 and positive 2. I can also see that if I plug in like 1 into this function, I'm going to get a negative velocity. So it's negative from 0 to 2, and it's going to be positive from 2 to 3. So this means that the total displacement is going to be the integral from 2 to 3 of t squared minus 2d dt minus the area, which was 0 to 2 of t squared minus 3t. So in both cases, my antiderivative is the same. I'm going to have t cubed over 3 minus t squared. I'm going to evaluate that from 2 to 3 and then subtract it being evaluated from 0 to 2. So when I plug in 3, I'm going to get 27 divided by 3, which is 9 minus 9. Then I subtract off it being evaluated at 2, so that's 8/3 minus 4. Then I have to say minus this thing evaluated at 2 again, which is 8/3 minus 4. And then when I plug in 0, I get 0. So this gives me 0. When I subtract 8/3 minus 4, I'm going to get a negative 4/3. So it's negative times a negative, so it's a positive 4/3. And then over here, I'm also going to get a negative 4/3, but it's multiplied by a negative, so it becomes a positive 4/3. And so the total area is 8/3, or the total distance traveled in this particular section.